All right, so it says Jada received a gift of $180. In the first week, she spent a third of the gift money, and she continues to spend a third of what is left over each week thereafter. Okay, so the first, or I'm sorry, 0 weeks, how much money does she have? 180. And what would be a third fifth? Okay, so we're going to take 180 and subtract 60 from it, right? So this would be 120. Okay, what would be the next one? Be 60. Wouldn't that be half? Okay, so we want to do a third of 120. How do we go about finding that? Divided by what? Divided by 3. Okay, so what would that be? 40. Okay, so 120 minus 40 is what? 80. And then 80 divided by 3 would be what? It's okay to use a calculator. 80 divided by 3. 26.666, but close. All right, so that's going to give me like 53.3 repeating, right? Okay, which equation best represents the amount of gift money in dollars she has after T weeks? Okay, so we know that we've talked about this equation, right? Where A is the initial and B is the rate, right? So let's kind of test this theory out. If we took 0 and we plugged it into this first equation, do we get 180? If we take 0 and we plug it into this equation, so we're going to type this into our calculator, do we get 180? Can somebody type that in their calculator and tell me, do you get 180? I would practice typing this in for sure, because you're going to need it this week, either on Desmos or the yellow calculator, whichever one you feel comfortable with. Okay, so when you plug that in, you got what? You got 180. Okay, but if you plugged in 1, do you get 120? No. So it would not be A. Would not be A. The reason why is because she spent a third. What? How much is she actually keeping? She's keeping what? 2/3, right? Okay. So if we did on the next one, if we plugged in 0, we would not get 180. So it would not be B. So the answer would be C. We're going to talk a little bit about how this equation is very similar to something that looks like this. We're going to talk about this rate later on. Okay. All right. Go ahead and take a look at this paper. It says exploring exponential graphs. Okay, so you're going to use Desmos on this one. And I'm going to give you about 15 minutes to kind of work with a partner. And you're going to answer these questions. Okay, so you're going to use Desmos to graph each of these functions. And you need to practice graphing this because this is going to introduce transformations in just a little bit. Okay, so take a moment. You're doing part 1, part 2. I think there's a part 3 on the back. Yeah. Okay, so you're going to go all the way to part 3. Okay, and then we're going to kind of chat a little bit. Once you get to part 3, kind of stop where it says wait for your teacher to move on before you move on to part 4. Okay, so you're going to do part 1, part 2, part 3. Okay, I'm going to give you about 10 minutes. And in that part 1, each of the following functions, F, G, H, and J, represent the amount of money in a bank account each year. They're written in this form, A times B raised to the X. So the initial amount, which is this A, look at all of these different functions from part 1. They're all the same, right? It's just the B that changed. Okay, so what did you notice with the b values? Like from 2 to 3, what was the difference? From 2 to 3, what was the difference? Kind of like from this red to this blue. What was the difference? Huh? Okay, let's maybe phrase it the bigger the number, like here, the bigger the b, the more it stretches, like the more it's pulled up. Okay. Now, when we had something like, let's say 0.5, okay, what happened? 0.5, we went what? Down. Okay, so we decreased. Okay, so anything that's less than 1 is going to be decreased. 2. All right, so looking at part 2, it says here are the equations defining functions p, q, and r. Okay, so looking at these, what's different on these? What's different on these? The initial value, right? Okay, so with that being said, they're all kind of going at the same rate, but they're just crossing the y-axis differently, right? So the y-intercept is going to be different. Okay, whatever that initial amount is out in the front, that's your y-intercept. Most of the time. Unless it's got a transformation, which we're going to talk about it in a second. So the y-intercept is different. Okay, now here's the important part. This 5 times 2 raised to the x, all of that is the same for these 4, except the stuff on the outside. What'd you learn about this stuff? Like, how did this impact it? How did this impact it? Okay, so this red one is -1. This blue one is +2. The green one is +5. The purple one is -3. So remember how I just said my statement about the initial amount being the y-intercept? Well, is that the case with this red one? No, how much is it off by? That -1, right? So when you're doing these types of functions where there's something like added or subtracted on the outside, that's going to change your y-intercept. So we don't want to just say, hey, this front piece is the y-intercept. If there's nothing written out here, yes, it would be. But this moves things, moves the function up and down. This moves the function up and down. Part 4 came directly from a question that we have seen before in various places. So go ahead and take a moment. You're working on part 4 and part 5. So let's chat about this one. Go ahead and go back to your notes. Okay, so you got 3 different exponential functions, which could be defined as the function of g. Okay, so we've got functions f and h are given by that equation, and then h of x is given by that equation. Which of the following could be the function of g? Okay, so we see h is right here. We see f is right here, and we're trying to figure out what g would be. What's going to help us decide that? What would be the y-intercept of g? Looking at our graph. What would the y-intercept be? Okay, so let me help you with this. H has a y-intercept of 20. Looking at this equation. So what is g going to have a y-intercept of? 20. So that's either going to be A, B, D. Now here's the tricky part. G is kind of like more pulled up than F is. So what would be the b value? What would be the b value? Would it be 1.5, 2.5, or 4.5? So G is like more pulled up than F is, okay? Or even looking at this, we've got H has a B value of 4. We know that it's going to be probably less than 4, but it's not equation D. So which one would it be? Either A or B? Why do you say A? Okay, so what I'd like for you to do is I want you to take this equation and graph it with this equation and this equation and see if you get this picture. All right, so taking those equations, what did you see? Okay, so again, I would plug these into Desmos. And that's going to give me 10 times 2 raised to the x. It's going to give me 20 times 4 raised to the x. And 20 times 1.5 raised to the x. And some of these you have to actually zoom out. Okay, so looking at this versus this, we see that they both cross at 20, so that's good. Is this green line in between the blue and the red? Yes. What about our other option? It was 2.5. That's a little bit closer to that blue one, right? So is this more accurate or is it 1.5? Probably that 1.5 because there's a little bit of a space, right? Okay, so my answer is going to be most likely A. Okay, there is a question like this on your interim final. They always ask some type of like one of these types of things, but they don't actually give you the actual graph. Okay. All right. So I want to like give you better notes. I feel like that's always a struggle when we go through that kind of stuff. Go ahead and look at the other little packet that you picked up. There it is. Okay. So I'm a very visual person, and when we start talking about transformations, I've got to see them, and like you got to tell me exactly what you mean. So on here, we've got this equation. All right, we talked about a times b to raise to the x, but then we have this little h and k. So h is going to be the horizontal shift. K is going to be the vertical shift. Okay. This is going to move left if it's positive. This is going to move right if it's negative. It's going to move up if it's positive, and it's going to move down if it's negative. Okay, A is greater than 1 is going to represent a vertical stretch. We've talked about that before. If it's less than 1, it's going to be a compression. If A is negative, it's going to be reflecting. And this is honestly, I feel like this is across the, here, hold on, let me graph this really quick. Looking at this, if I had 2 times 3 raised to the x, And then I made this guy negative. That's reflecting across the x-axis. Okay, so this is reflecting across the x-axis. So this says describe the transformation. So we have 3 raised to the x. That's going to be our base. So anything that's raised to the x power, we're just going to kind of like ignore. Okay. And what is this plus 5? Well, looking at our little like equation, we had something that looks like this. So that plus 5, that k value, does what to our equation? It moves it up 5 units. Now, this question also asks us to identify the parent function. The parent function is what's underneath this little blob. So looking at this, our parent function is going to be y equals 3 raised to the x. Okay, your parent function is what is like the base. Okay, looking at the next one, again, our base is going to be 1/4 raised to the x. And now we're going to look at the other stuff. There's this number that's out front. So that's going to be a stretch of 2. And we've got -1, so that's going to be right 1. And our parent function is going to be 1/4 raised to the x. Can you try 3 and 4? Describe the parent function. Thought about this. Again, this should be pretty quick. That negative out front is going to be that reflection. That +7 is going to be up 7. That +2 is going to be left 2. A lot of people mess that one up. And then your parent function is whatever your base is raised to that exponent. So parent function is going to be 4/3 raised to the x. Over here, we've got a compression of 1/2. We've got right 4 and down 2. Your parent function is going to be our base raised to the x. First, so it says graph each function and then identify its key characteristics. You might want to use Desmos for this one, but I'm going to do a quick little graph in just a second. So biggest thing when you type in this into Desmos, if you don't put parentheses around that exponent, it won't keep it in the exponent. It'll bring it down. Okay. So looking at this, we got 2 raised to the x plus 5. We're finding the domain, range, in behavior, y-intercept, and asymptote. Okay, so looking at this, our domain is always going to be -infinity to +infinity. So domain is always going to be -infinity to +infinity. Range is going to be whatever our asymptote is to +infinity or -infinity, depending on the equation. So what's our asymptote here? Where does it approach but never touches? Well, if I zoom out, where does it get closer and closer to? What value? Well, it's on the x-axis, right? And we call that line y equals 0. So our range is going to be from 0 to +infinity. Our asymptote, we just had that conversation, is going to be y is equal to 0. Our in behavior is going to be as x is approaching the right-hand side, it's going up. As x is approaching -infinity, our y is getting closer and closer to 0. Our y-intercept, we can see that by either zooming out, 0.32. So 0, 32 is our y-intercept. Notice how it's not the number that's out front. So you can't just like assume. You got to plug in 0 into the equation. Okay, so on that first one, domain is going to be from negative infinity to positive infinity. Okay, like that's pretty simple. For range, you need to identify your asymptote. What was your asymptote on this one? What's your asymptote on this one? You got graphed it. You got y equals -2. Okay. You can also see that with that number that's out on the end. Okay. All right. So our range is going to be from -2 to positive infinity, right? Okay. And again, if you graph it, then you can see that. We got 1/3. Oh, there we go. Okay. Now our y-asymptote, I'm sorry, our y-intercept is going to be 0, -1, 0, -1. Zero, -1. And then as we're going to the right, it's getting closer and closer to -2. As we go to the left, it's getting closer and closer to positive infinity. Okay. Hopefully this is getting easier each time. Okay, I am going to skip a little bit. I want us to classify these, whether they're exponential growth or exponential decay. So this is on the next page. Oh, remember, if the B term is bigger than 1, then it's growth. If it's less than 1, it is decay. Just because it's a fraction doesn't mean, hey, it's automatically going to be decay. Okay, so looking at this, our B value, that's the one that has the X attached to it, okay, is bigger than 1. So is that growth or decay? Growth. Okay, can you take a moment? Can you do 2 and 3? Like 20 seconds. All right, so that would give me decay on this last one and growth on the second one. The reason why I say growth is if I type 6/5 into my calculator, it's going to be bigger than 1. It's going to be like 1.2. Okay. All right, identify the parent function and describe the transformation. Same thing we were doing on the front. So go ahead and take a moment, identify the parent, and then describe the transformations. Okay. So the parent function on this one should have been 4/5 raised to the x. And then this +2 means I'm going to move it left 2. Okay. The parent function for this one is 2 to the x. And that means that we're going to have a reflection, a stretch of 3, move right 1, and up 7. And again, all that's going to come from up here. Most people mess up the -1. They always think it's left instead of right. Okay. Okay. Go ahead and take out your review. It looks like this. It's the one that you got a while ago. Actually, it was like Thursday. But you should have worked on Friday. And I want you to turn to the page that is talking about exponential transformation. Okay. And I want you to answer 5 and 6 on there. Oh, on here, describe the transformations as relative to the parent function at 4 to the x. Okay, so here's the parent function. So this -2 and this +8, what does that mean? Well, that means we're going to move up 8 and to the right 2. That -3 out front, the negative means we're going to reflect. The 3 means that we're going to stretch. The +1 means we're going to move to the left 1. Okay, so on your mastery check tomorrow, this is one of the questions. Okay, it literally asks like, what's the transformation? Okay, questions on that. That's one of your questions. Okay, go ahead and take a look at 7. We're gonna write the equation. Okay, on number 7, it's very similar to one of the questions that's going to be asked. Okay, it's going to ask you to write the equation. So if you're starting with 0.5 raised to the x, okay, 0.5 raised to the x, and they want you to horizontally shift it 10 units right. Remember, this is our equation that we're given. If we're moving 10 units to the right, we're just going to say minus 10 in the exponent. We're going to shift 4 units down. So that's going to be minus 4. And we're going to have a reflection across the x-axis, which is negative. And then it's compressed vertically by a factor of 0.25. So we're going to put 0.25 out front. Okay, so here's our equation. So we got y equals negative 0.25 times 0.5 raised to the x minus 10 minus 4. Okay, this next question is not on your mastery check, but it's something that I think we should go over. Okay, it says take this line and then move it 2 units down, stretch it by 3, and then add 1, or I'm sorry, move it 1 up. So we're gonna do these, I'm gonna do these in different colors. So first we're gonna take this in minus 2. So we're gonna take like all of our dots and subtract 2 from it and move it down. And when we do that, we're gonna get this little pink line. And it moves all the dots 2 units down. That's all it does. If we stretch by a factor of 3, that means we take our y values and we multiply them by 3. So if I take 1 and multiply it times 3, 1, 2, 3. If I take 1, 2, 3. If I take 3 and multiply it times 3, that's going to give me 9. Okay, so it's going to look something like this. It might be a little bit higher, but again, rough sketch. Okay. And the next one is going to add 1. So you're going to go back to the original function and then add 1. Oh, I should probably read better. So you're going to take h of x. H of x. It should have been f of x. Sorry. You're going to take the original function and you're going to add 1 to it. So you're going to move everything up by 1. It's going to look something like that. Okay. There is a question on your test that is very similar to that. Okay. Now, not on your mastery check, but on your test. Yes. Okay. Go ahead and take a moment and try 9. You're describing all the transformations. Okay. Then you're going to tell me what the asymptote, the y-intercept, all are. Okay. Be careful about which function it's actually talking about, whether it's g of x or f of x. Describe the transformations from here to here. So we have a negative symbol out front, so that's going to be a reflection. We have that plus 2, so that's going to be up 2. And we have that plus 1, so that's going to be left 1. Doesn't matter what order you say those things in, it's all up to you. Okay. Now the asymptote is going to be at y equals 2 for g of x. Notice how they're talking about g of x. On the next one, it's asking about f of x. So if we plugged in 0 into this equation, that'd be 5 to the 0 power. What is anything raised to the 0 power? 1. Okay, so our y-intercept is 0, 1. If we plug in 0 into g of x, that's going to give me negative 5 raised to the 0 plus 1 plus 2. So 0 plus 1 is 1. So this is going to give me -5 raised to the first power plus 2. -5 plus 2 is -3. So this is going to have a y-intercept of 0, -3. Questions on that?